This is the USB audio interface project for CSE 145. Let's say you're trying to record a quick segment on a guitar or a synthesizer to upload to Bandcamp. Or maybe you want to set up a microphone for recording a podcast. Perhaps you're even working on voiceovers for a class project at 11 p.m. Whatever the case is, these are all analog sources that use oscillating voltages to represent sound. However, your computer is a piece of digital hardware. So how do you get the audio from one to another? This is where the device we've built comes in. It allows you to amplify and digitize audio in order to save it on your computer. Great, so how do you make one? The first step was to do some research on similar devices and find what specifications and features are essential for a good user experience. This included having both XLR and quarter-inch inputs for balanced and unbalanced sources. Each channel needed about 60 decibels of SNR to prevent audible hiss and hum. Dynamic microphones have extremely low source amplitude and need about 90 decibels of gain on the preamp. Clipping LEDs are important to provide intuitive visual feedback to let you know when you're subjecting your fellow Zoom participants to this. The interface needed to work on all platforms without installing any drivers, and lastly, we need a sturdy enclosure to protect the PCB from ESD and damage. These specs formed the goals for the project. With all these specifications gathered, it was time for more research. This time about technical details of microphones, USB audio, and preamplifiers. All this was brought together to create a systems diagram. Specific parts were chosen, and this diagram was then turned into a schematic. A design review followed, changes were made, and then a PCB layout was created from this schematic. There was another design review, and I scrapped the layout, started over, and then finally ordered the PCB and components. In the meantime, firmware was written. A USB middleware library called TinyUSB helped abstract away many of the USB details. Unfortunately, TinyUSB didn't support the features needed for audio on the microcontroller, but this was quickly patched in. After the board was assembled, it was time to merge the two halves of the project together, which involved I2S for ADC communication, DMA for moving samples, and GPIO for the LEDs. The mechanical enclosure could have been 3D printed or laser cut, but I opted for wood panels and brushed aluminum for aesthetic reasons. The wooden sections were built with standard woodworking techniques, and the faceplate was designed in CAD and then CNC routed. After the device was built, it was tested with a signal generator and verified to meet the specifications. However, bench verification only provides numerical results, but for audio, qualitative results are just as important. For this, I had some help from my good friend Patrick to record some demos with real instruments. We tested a flute, a bass, and also a didgeridoo. Lastly, Patrick played a few instruments in layers for a more realistic test. With all these tests complete, the last step of the project is to publish all the supporting documentation to the project's GitHub repository. This includes schematics, board files, precompiled firmware binaries, and assembly instructions. This documentation can hopefully provide enough information for others to create their own DIY audio interface.